Good morning. Hopefully yesterday was a good introduction to hydrocarbons for you and you understand that there are different groups of hydrocarbons based on how the atoms are bonded together. Today we're going to focus on how to draw some of these organic molecules, 3 different types of structures we can draw, and how to go between those 3 before we dive into the characteristics of each type. Important to note that when we talk about organic chemistry, we're talking about the study of compounds that have carbon as the building blocks, so long chains of carbon molecules. Sometimes there are other elements added in, but the main idea is that it's built mostly of carbon. So sometimes we have oxygen and nitrogen and sulfur, and usually a lot of the halogens, but for the most part it is carbon only. Basically, why is it important? Organic molecules are around you every day. So we use organic molecules to make clothes, to eat, our medicines, what a lot of your body is made out of, lipids, proteins, enzymes, and so on. So to understand the chemistry of these things, we have to understand the chemistry of the molecule. So which of the following represents an organic compound, and why do you think so? So, I guess my number's screwed up in this. So what I want you to focus on is which ones are made up mostly of carbon. Hydrogen and oxygen are generally there as well. But we're looking for a chain of carbon molecules. So if I'm looking at the choices that I've got here, this one is made up of carbon, hydrogen, and oxygen. That one's considered an organic molecule. B has a long chain of carbon as well, 6 carbons. Again, with hydrogen and only oxygen. So those 2 are definitely considered organic molecules. C, however, is not. So it's got no carbon there. So C is not an organic molecule. And D, although it has 1 carbon, carbon is not the backbone of that molecule. So it is not an organic molecule either. E does have a long chain of carbon, so that would be considered organic. F, it is not a long chain, so it is not considered an organic molecule. Okay, so we kind of skipped over a unit before we got to organic chemistry because I thought that organic chemistry would be easier for you to learn distance-wise. So we didn't talk about molecular formulas yet. A molecular formula basically is what we've been considering as the chemical formula for a compound. So it's telling me the exact number of atoms in the molecule. So again, I don't know what happened to my type, but those should be subscripts. So C2H2. When I do a structural formula, this is kind of like what we were doing when we were doing bonding and had to draw the shape of the molecule. So a structural formula shows how they are connected together. So all the atoms are there, but it's just showing us how to connect them together. So the pictures that you see there are all examples of structural formulas. So what I want you to do is take a moment right now, pause the video, see if you can find the molecular formula. So just the number of C's and the number of H's and O's and N's for each of these molecules. Okay, so the first one is going to be C2, because there are 2 C's, and H4. This one, again, we're just going to count. We've got 3 C's and 6 H's and 1 O. It generally goes in the order carbon, hydrogen, then oxygen. So again, doing the same order for this one, I've got 3 C's, and if we count up our H's, we've got 8 H's, and then we've got 3 O's. And then the last one, we've got 1 C, 5 H's, and 1 N. Okay, so important thing to remember when I'm drawing these molecules is that carbon always has 4 bonds. So every structure you draw should have 4 lines coming out from the coming out from the carbon, and hydrogen can always only have 1 bond, so 1 line coming out from the hydrogen. So we know that carbon can form single, double, and triple bonds, but I have to remember that no matter what I draw, I am still looking for 4 lines from the carbon. So when you're given a formula and you're trying to figure out what the structure is, a lot of it is trial and error, but what you're going to have to make sure is that you check that every carbon has only 4 lines coming from it, and that you've got the correct number, of course, of carbons and hydrogens. So in each of these structures, whether I've got a double bond or a triple bond, every carbon still has 4 lines coming out from it, and every hydrogen only has 1 line. Okay, so again, oxygen appears all over the place in organic molecules, but again, remembering that oxygen can have a single or a double bond because it needs 2 lines connecting to the oxygen. Oxygen needs 2 bonds to be stable. So in every structure, again, I'm looking for the 2 lines to oxygen. It can be a double bond or it can be 2 single bonds, but there needs to be at least 2 lines to every oxygen. Okay, so if I'm doing this structure and I'm trying to figure out how many hydrogens there needs to be, again, I'm just counting the number of lines to carbon. So looking at the first one, I need to make 4 lines for every carbon. So I'm going to have another hydrogen here, here, and here. And this carbon's already got 3, so I only have room for 1. Again, this next carbon only has 3, so I only have room for 1 more. And the carbon on the end only has 1 bond, so it's got room for 3. And it's important to note that in these structures, we often leave off the hydrogens just to make it much simpler. So you'll just see those sticks, and then you realize at the end of every stick, there is a hydrogen atom. So sometimes I get lazy and I draw them like that without the hydrogens, or you can completely fill in the hydrogens. Just make sure that you're not drawing it too sloppy so I can't tell whether it's a line that's supposed to contain a hydrogen or not. Okay, so for the next one, again, I'm going to count my lines. The first carbon only has 1 line, so it's going to need 3 more hydrogen. Again, this one's got 2, so it needs 2. Oxygen already has its 2 bonds, so no more hydrogens added there. And this carbon's got room for 2 more, and this one's got room for 3 more. Okay, and then the last structure, I've got that double bonded oxygen, so oxygen is all happy by itself there. The next carbon has 3, so I'm going to add 1 more to make 4, and then this carbon needs 2, and this carbon needs 3. Okay, now it's your turn. Pause the video and see if you can give me 2 possible structures. I'm going to suggest you start with carbon chains first. So just like in the previous examples, we had the carbons with their bonds all filled out first, and then I added in the hydrogen. Okay, give it a try. Okay, so then I'm going to take up that last slide. So hopefully you gave yourself a little bit of time and you tried to draw them. Let's start with the first one. So I need 2 carbons and 6 hydrogens. So you may have noticed that how you attach them together actually determines how many hydrogen you need. So if you tried to add any double bonds, you would have noticed you didn't need as many hydrogens. So we're going to talk about that a little bit later. So I'm going to just stick with single bonds today. So there's my 2 carbon chain. So now I have to attach the oxygen. And so now I'm going to fill in my 6 hydrogens. So 1, 2, 3 here. This carbon's got 2, so I've got room for 2 more. 1, 2. And that gives me 5, so I've got 1 here for the oxygen to complete oxygen's octet, so I've got 6. Now, I need to change that structure that has the same number of hydrogens. So the only thing I can do is actually stick the oxygen into the middle of my carbon chain. So now oxygen is happy and I've got room for 3 hydrogens on this side and 3 hydrogens on this side. Sometimes it takes a little playing around trying to bond them together to find out how you can do it and use all of the atoms. Okay, again, letter B. When I'm doing this one, I've got a 5 carbon chain. So let's start by drawing 5 carbons. Just got to get my pen ready there. There we go. 1, 2, 3, 4, 5. Now, if I just went and filled the hydrogens all out, that would give me too many. I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't have 12. So I need to add another carbon bond that's going to eliminate the need for those extra hydrogens. So now if I do that, I've eliminated the need on those 2 carbons for 2 extra hydrogens. So I should get to 10. 1, 2, 3. That one has 3, so it only needs 1. So that's 4, 5, 6, 7, 8, 9, 10. So that's one possible structure. I can move that double bond around and get another possible structure. So I can do 1, 2, 3, 4, 5 carbons here. And again, I'm now just going to add my hydrogen. Again, I need that double bond first to take away the spots. So then I've got 1, 2, 3. That carbon has 4 bonds, so it's not going to get any hydrogen. 4, 5, 6. Now this one's got 3, so 7, 8, 9, 10. Again, so you may have a couple other different options, but those are 2 options for C5H10. Now let's take a look at the last one. 3 carbons, 7 hydrogens, and nitrogen. So again, I'm just going to start with a carbon chain. That's probably the easiest way to start here. I'm going to draw these ones in red. So 1, 2, 3, and then my nitrogen. Let's try that way. Now nitrogen needs 3 bonds to be happy. So if I go ahead and fill in my hydrogens, I've got 7. So if I left my structure just like this and I tried to put the hydrogens in, what I would notice is I need more than 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9 I would need. And that's not allowed. I've only got 7. So somehow I have to change my structure. And what's going to happen is the same thing that happened in the last one. I need to put a double bond in that reduces the amount of carbon I need by 2. So if I throw my double bond there, that leaves me 1 hydrogen, 2, 3, 4, 5, and then the 2 on nitrogen to make 7. Okay, again, I can just move my double bond around, or I can move my nitrogen atom around, or I can do both. So again, this time I'm going to throw my nitrogen in the middle. You don't have to do this. You can just move your double bond around, but it's just another example. I still need that double bond somewhere though, to eliminate 2 of those hydrogen that I need if I was all a single bonded chain. So if I just throw it in there, I'm going to give everybody the hydrogens that they need. 1, 2, 3, 4, 5, 6, 7. Okay, so lots of different structures that I can draw. These are called structural isomers, and we'll talk more about those in the coming days.